Hyperbolic sine and cosine. This is something you possibly have never seen before. And when you look at the definition for it, it could get pretty scary. I think in the book that I looked at, it wrote it like this. I'm going to do hyperbolic cosine as the example. They call it e to the x plus e to the negative x over 2. Why? Why? This scares students away. I'm not going to write that. Okay, I am going to write it, but I'm going to give it to you in a different way. And bear with me for a minute here, but I think of things in terms of left and right because I'm a very slow person. I'm not smart. I need to have this broken down into components. So I'm going to write it like this. Because when I'm learning calculus, I need to understand what my sections are, what my pieces are. And these are two separate pieces. And the reason I write it this way is to show you that hyperbolic cosine is a composite of two concepts. Now, don't get me wrong. It's a beautiful function on its own. But it needs to be understood by its components first. Then we can use it in whole. And besides, when you're taking derivatives, it's easier this way, right? So I want you to just picture for a minute what this looks like. E to the negative x, anything to the negative x is going to go like this. And when x is at negative infinity, this is going to be positive infinity. And over here, when x is at positive infinity, you're going to get 0. So this is a function that basically decreases forever. And when I look at e to the x, I get this, where it starts off at negative infinity and is worth nothing, but then as time goes by, its value approaches infinity. And what we're taking here is an average between them. That's why it's divided by 2. Half of each, and then they're put together. So think about what this is going to create for a minute. We don't even need the formula. I'm going to try and hide it just to make a point. On the far left side, we have something that's at infinity. And we're adding it to 0. So this negative x version is absolutely in charge in the negative space. So I'm going to draw an axis over here like this. And I'm going to put this at negative infinity, infinity. I don't know what's above it, but whatever. But then as I move to the right, as I'm moving to the right, and along this graph, that obviously is descending. You can't go up from infinity, right? In the middle here, and then in the middle here, you have seen a rapid decline from infinity to some understandable value. And this has had some slight increase from 0 to some equally understandable value. When I put them together, at x equals 0, it's going to have looked like this, where it basically bottoms out. Like when x equals 0, you can almost think of it as being in the middle of these functions, since they go from negative to positive infinity. But then as I continue, what should I use for this? Gold. As I continue, this function becomes nothing. And this function rockets to infinity. So when you see them added together, you're going to see them go like this again. Then it'll be at like infinity, infinity here. But the important thing to understand is that when I'm on the left side of the function over here, it's dominated by my e to the negative x function. And as it loses steam, this guy over here picks up. So when you look at hyperbolic cosine, which is what this is a graph of, and you see that there's a minimum here, well, that's all well and good. But I want you to very, very clearly understand how these two sections come together to create this hyperbola. It's very important to see that. And now let's play around with hyperbolic sine a little bit. As you might expect, it's like second verse same as the first, because sine and cosine is not supposed to be some kind of like hidden thing, right? Sorry, I got to put an ice pack on the back of my screen. It's getting so hot. Anyone want to buy me a new screen? Okay. Hyperbolic sine is e to the x. In fact, I'm not even going to do the e to the x part first. Let's do the negative e to the negative x over 2. And that is plus e to the x over 2. So how is it different? Let's come back up to cosine. This is e to the minus x plus e to the x. Here you have negative e to the x, negative x. That's the only difference. That's the only difference. But look at what it does. Instead of e to the negative x, that's out, you're reversing it on the over the x-axis like this. And then you have a regular e to the x here like this. So it should be no surprise that it combines to produce this. And the reason for it is because just like in the previous function, when this is at negative infinity, this guy here is at 0. So when I add them together, this function is entirely in charge of what the result is down here. But as I approach positive space over here, this being infinity is going to be in charge of why this graph looks like this over here. So the graph of hyperbolic sine, much like hyperbolic cosine, is at first determined by the e to the negative x function, and then as we go forward, this guy is going to be in charge. I want to just make that so clear before we do any math, before we figure out all of this, that you take a look at these separate individual composite pieces and say, e to the minus x is what's doing this. E to the positive x is what's doing this. And as one descends to 0 and becomes irrelevant, the other becomes stronger. And you can go back and forth like this all day. So I'll tell you what, let's find the derivatives to these, but I'll do that in explainer video number 2.